So by way of background, disease is really one of the largest costs in pork production, and it's often quite difficult to manage once it's in the barns. For the pigs themselves, there's a negative impact to animal welfare. And there's obviously, because we have to treat the sick animals, there's implication for food safety and, in fact, antimicrobial resistance. Disease resilience, or resilience, is the capacity to recover quickly from difficulties and toughness. And you might say, well, what does that really mean? So my elevator speech to people is that if you take a group of healthy pigs and you expose them to typical pig diseases, there's always some of those pigs that will get quite sick, which is what we expect, and then there's some of the pigs that either don't get as sick or they don't get sick at all. And from our project's perspective, those are really the pigs that we're interested in finding out how come they can grow as well as other, and oftentimes better than other pigs, even after being disease challenged. The resilience phenotype is quite complex, and it encompasses genetics, genomics, immune response, microbial colonization, feeds and feeding management, and maternal and litter environment. Really, from our project's perspective, we're looking at a lot of these different phenotypes. Any Genome Canada project always has a GELS component, and what GELS stands for is genomics and its ethical, environmental, economic, legal, and social aspects. So really, the pork industry can be considered unique in its structure, trade, and societal concerns about production practices. And these characteristics can affect societal acceptance associated with the use of genomics. We don't really know what the societal impacts of genomics are in the pork industry. And the goal of the project is to identify and measure the social value in breeding for disease resilience in pigs. So I promised that I'd highlight activity 1. Essentially what we've done is we've taken cedar pigs, sort of normal health pigs, and we've seeded the barn with typical pig diseases that you would find out in commercial farms. So this particular challenge model, we've taken barrows, so that's castrated male pigs, from the various genetic company multiplier farms, and we've transported them to Quebec. For the first 5 days, we let the pigs acclimatize to their environment, and then we actually take some samples. So at 40 days, as you can see on the slide, the pigs are then moved to the CDPQ where we've got our sort of resident pig diseases, and we are busy collecting samples from these pigs on an ongoing basis as the various batches go through the system. So we do have some preliminary results to share. What you're seeing here is from a group of pigs that were disease challenged at CDPQ. It's a little bit hard to see on the slide likely, but there is a black line that shows the sort of a typical growth curve for what's expected. That is actually data that was collected from CDPQ on groups of pigs that had gone through their facility. So we're using that as sort of the benchmark of the type of growth that one could expect in this barn. Now, as you'll see by the multitude of colors and whatever there, and the legend, you'll see that there are some pigs at the top end of the scale, the ones with the blue lines. There are blue lines throughout, but just look at the ones at the top. And those are the pigs that were introduced. They're high health pigs. They were introduced to the mixture, the nice cocktail of diseases that we have in the barn. And those pigs, if they did get sick, you wouldn't know it because they just kept growing actually better than what was expected. And so from a project perspective, those are really the pigs that we are most interested in learning more about. We take our resilience phenotypes and we then look at the genetics and form a link with the idea then that we would develop some genomic tools for the breeding stock companies to then be able to incorporate into their various genetic systems. And that's sort of the goal is to provide that for them so that then, in years to come, and the progeny that results from this, the pigs won't require as much antibiotics. So it's just a healthier and more disease-resilient pig population. We've run over 1,000 pigs through the Grow Finish Challenge model. Of course, some of these pigs are still in the system. We keep them there through till market, and some of those pigs haven't quite reached market weight yet. The growth, performance, and health status monitoring is ongoing and actually will continue till probably early year 4. That's when the last of the pigs from the various genetic companies have gone through.